This program will help you, the professional truck technician, understand diagnosis and troubleshooting of the Eaton Fuller CEEMAT transmission. This tape illustrates the procedures you'll find detailed in the Eaton CEEMAT troubleshooting guide. It's important that you review the first two tapes in this series, CEEMAT driver instruction and CEEMAT theory of operation, before watching this tape. They'll provide you with the background information that's necessary to really understand the CEEMAT. You'll also need the information in those tapes, as well as the information we're going to present here and in the troubleshooting guide, to complete the worksheets in the accompanying workbook. So, since you're watching this program, we can assume that you know how to drive the CEEMAT, that you understand the theory behind the CEEMAT, and that you're ready to learn how to diagnose the CEEMAT. Let's get started. The CEEMAT can be diagnosed on two levels, depending on whether the complaint you've received is fault code driven or symptom driven. Fault code diagnostics troubleshoot components that are electrically connected to the CEEMAT electronic control unit, or ECU. And fault code diagnostics generally don't require special tools. All you need are a volt-o-meter and the troubleshooting guide. System-level diagnostics troubleshoot CEEMAT and vehicle mechanical components that affect CEEMAT performance. And system-level diagnostics require special tools like a handheld diagnostic tester, air gauges, and hydraulic pressure gauges. Now, if you're servicing a complaint that is fault code driven, you follow one set of procedures. If the complaint is at the system level, you follow another set of procedures. That's why the CEEMAT troubleshooting guide is a valuable tool. On the page labeled How to Use Your Troubleshooting Guide, you'll find a fault tree that will guide you step by step through the diagnostic process, regardless of whether your complaint is fault code driven or symptom driven. Using these procedures consistently means it's likely that you'll isolate to the right component the very first time. Now, here's how you determine whether to use fault code diagnostics or system level diagnostics. It's simple. Just follow the fault tree. When a complaint is received, the first thing we do is check the service transmission light. You do this with the ignition key on. If the light is flashing or constantly on, the CEEMAT has stored a fault code. That sends you to fault code diagnostics. Just as simply, if there's a transmission complaint but the light's not on, you follow system-level diagnostics. Now, to keep things clear, we'll discuss system-level diagnostics in another tape. This tape will focus only on fault code diagnostics. So, assume that the service transmission light is on, either constantly or flashing, when the vehicle comes to you. Again, the fault tree gives you the steps to follow. In fault code diagnostics, we begin by retrieving the active codes. Now, as you'll recall, the CEEMAT driver instruction tape told you that a flashing service transmission light means that the CEEMAT has detected a problem in one of its circuits and has stored a fault code in its memory. In the case of a flashing light, the problem usually isn't serious enough to prevent the truck from being driven. So, although the CEEMAT may enter limp home mode, it's likely the truck will be driven to your facility. Now, a solid light indicates a more serious problem, one that suggests that the truck not be driven, but towed to your repair facility. Either way, you need to retrieve the stored codes. Here's how you do it. Stop the truck, put the gear shift in neutral, and set the parking brake. Now, the CEEMAT displays the fault codes by flashing the transmission lamp in sequences. One flash means number 1, 2 flashes means number 2, etc. So, when you're ready, turn the key off on within 5 seconds. Don't worry if the engine stops. Just be careful not to engage the starter. Just watch the lamp. It'll flash 2-digit fault codes. For instance, the first code is 3 flashes, 2 flashes. That's code 32. Then 2 flashes, 1 flash. That's code 21. When the list is complete, it repeats. Now, even though special tools aren't required for fault code diagnostics, you can use a handheld diagnostic tester to display stored fault codes and their definitions. Here's how you do it. Trucks equipped with a CEEMAT have a diagnostic connector in the cab. The exact location can be different with each truck. Connect the handheld tester equipped with the CEEMAT diagnostic cartridge and turn the key on. Then press key 1 to get past the title screen. Press 1 again to select CEEMAT. Then 1 to select Fault Code menu, and 1 again to select Active Fault Codes. The handheld tester reads the codes from the CEEMAT and displays them on the screen. Again, the fault tree tells you the next step is to use Fault Code Diagnostics. All that means is that you should open your troubleshooting guide to the Fault Code Diagnostics section and locate the code number or numbers that you've retrieved. The guide will tell you exactly which test or tests need to be performed. That takes us to the next step in our procedure. Perform pretest. Regardless of which test you'll be performing, you must always perform the pretest. This includes a vehicle electrical test and a vehicle air system test. These pretests are a critical step. Without correct power, ground, and air pressure, CEEMAT can't function correctly. So you want to eliminate the vehicle electrical system and the vehicle air supply to the transmission as the sources of any problems before you proceed. The pretest also includes a note to check the transmission dipstick to make sure there's enough oil. Our first pretest procedure calls for a vehicle electrical test to check vehicle power and ground connections to the CEEMAT. If you're using a manual volt-o-meter, you'll want to be aware of range changes as you perform your tests. We'll note them on the screen during our test procedures, and of course, they're indicated in the troubleshooting guide. We'll be using an auto range meter here. Now, the first thing we do in a vehicle electrical test is measure the voltage across the battery. It should be between 11 and 15 volts. We've got a good reading here. If there was a problem, we'd need to look at the charging system or batteries. Since we're all right, we move on by disconnecting the vehicle interface harness connector from the transmission. Check battery power to the transmission by clipping the black volt-o-meter probe to battery ground and probe the cavity for pin L. The reading should be within 0.6 of a volt of the battery reading. Do the same thing to measure switched voltage to the CEEMAT at pin K. We should have 0 volts with the key off. Now turn the ignition on. We should get within 0.6 of a volt of battery voltage. If the voltage isn't correct, the troubleshooting guide recommends a repair procedure. Again, we're okay here, so we'll go on to measure the grounds. If the ground connector gets loose and gets high resistance, you can get system problems because you lose power. That's why you should always check the ground too. Turn the key off and measure the resistance between pin B and the negative battery terminal. Don't clip the black lead to the chassis for this test. You need to go right to the negative battery terminal. Resistance should be less than 0.3 ohms, so our reading is fine. Do the same thing with pin C. Once again, the resistance should read 0.3 or less. Once you've completed this test, you know that power and ground to the CEEMAT are okay. So let's move on to the air test. This transmission runs on air and electricity from the vehicle. If you don't have enough of either one, you've got a problem. So, for the air pressure test, first install a gauge in the diagnostic port on the transmission air pressure regulator here on the side of the shift bar cover. Start the engine and allow the system pressure to reach governor cutoff. Depending on the truck, that's 90 to 120 psi or 620 to 825 kilopascals or kPa. Pressure here at the transmission should be 75 to 85 psi or 500 to 565 kPa. If the air pressure isn't in spec, check the air supply source lines and connections. If the vehicle supply to the transmission is okay, replace the air pressure regulator. Now, turn the engine off and wait 3 to 5 minutes. Listen or feel for air leaks at the shift bar cover breather. If there's evidence of a gross air leak, you'll also see the gauge fall or hear air escaping. Of course, you'll want to fix those problems before proceeding. To do this, remove the shift bar cover. With an air nozzle, pressurize the shift bar housing at the auto shifter supply port. This will isolate the auto shifter gasket, and the shift bar housing from the shift bar cover assembly. If there's still a leak, you should be able to isolate it because you'll feel and hear the air. If you do, replace whatever is leaking. If you don't feel or hear a leak, the problem is in the ECU, and you'll need to replace the ECU. All right, referring back to our fault tree, the next thing we do is perform the test sequence. Now, in order to streamline this overview, we're not going to describe those tests at this point. We'll go through them step by step later in this tape. For now, we want to make sure you get a clear picture of the entire diagnostic procedure. So, let's continue as if we had performed the specified test or tests. The fault tree shows that we will also have determined what passed and what failed. And having done that, you also will have performed the remedy sequence and will have solved the problem, right? But notice that there's one more step in our diagnostic procedure: retest. It's important. You want to be sure that you did in fact fix the problem, and you want to be sure that other problems didn't creep up in the process. Now again, the troubleshooting guide includes all of these procedures. It's a good idea to have it on hand anytime you have to diagnose a CEEMAT. Of course, you can review this tape anytime you like, and if you still find yourself with questions, you can always count on your Eaton Road Ranger Field Marketing Network, 1-800-TCM-HELP. Again, the rest of this tape will walk you through each of the test procedures. Watch all of the tests so that you can complete the worksheets in the accompanying workbook. But in the future, if you're interested in reviewing a specific test, all you'll have to do is fast forward to the test procedures screen that's coming up. Each test in that section is introduced by series, 20 series, 30 series, etc. And each test has the specific fault code superimposed in the bottom right-hand corner of the screen. By scanning forward, you'll be able to locate and review the specific test you're interested in. One other thing. Now, it's rare that you'd pull a transmission to perform diagnostics, but to make it easier for you to see what we're doing, whenever possible, we'll perform our tests on a pulled CEEMAT. Now, before we review individual tests, let's take one more look at the process we've been following. The fault tree tells us that once we've received a complaint, we check the transmission service light first. With the light on or flashing, we move down the fault code diagnostics branch to retrieve the active codes using either the flash code sequences or by using a handheld tester. We then use fault code diagnostics by locating our codes in the troubleshooting guide in order to locate our test sequence or sequences and perform our pretests. Then, and only then, we perform the test sequence or sequences, determine what passed and what failed, remedy the situation, and finally, retest. So there you are. You have everything you need to perform fault code diagnostics. A flashing or solid service transmission light, a voltometer, your troubleshooting guide, and this tape for added support. So here come the tests. In the event you find yourself with a solid service transmission light, we've told you that that indicates the CEEMAT has detected a serious problem. But before you start digging into the transmission, there's the outside chance that the service transmission light is the problem. So it's a good idea in the event you get a solid light to check the light. Here's how you do it. First, turn the ignition switch off. Disconnect the vehicle interface harness at the shift bar cover. And use a jumper to connect pins B and G. If the light is on, there's a wiring fault in the service light circuit and it needs to be repaired. Now turn the key on. The service transmission light should go on. If it doesn't, replace the light and retest. If the problem persists, repair or replace the vehicle interface harness. If you go through the checks and nothing's wrong, something's wrong with the ECU circuitry. You'll need to replace the shift bar cover. If fault code retrieval is bringing up code 11, there's a fault in the shift bar cover assembly, and there's no additional diagnosis necessary. So, if the pretest passed, replace the shift bar cover. All 20 series codes are associated with the torque converter harness from the ECU. The torque converter harness is connected to the interrupt clutch solenoid, the lockup clutch solenoid, and the engine speed sensor. Now, code 21 indicates that the CEEMAT detected an electrical problem with the interrupt clutch solenoid. Code 22 indicates a problem with the torque converter bypass clutch solenoid. Test procedures for both codes 21 and 22 are almost the same. Disconnect the torque converter harness connector from the front of the shift bar cover. Now, probe the pins on the harness. For code 21, probe pins F and G. For code 22, probe pins B and H. In either case, the reading must be from 2.5 to 4 ohms. If it's below that, it indicates there's a short in the coil. If it's above that, it's open. There's no continuity. So, if it's not within range, replace the harness. If it is in spec, check for abrasions that might be shorting the wiring harness to ground. Then, connect one probe to a good chassis ground and use the other to probe pin F for code 21 or B for code 22. The reading should be open or infinity. If you go through the checks and nothing's wrong, something's wrong with the ECU circuitry. You'll need to replace the shift bar cover. Now, a code 23 tells you that the CEEMAT detected a problem in the engine speed sensor. The speed sensor mounted on the top of the torque converter housing picks up the engine speed from a gear on the torque converter. To diagnose, turn the key off and disconnect the torque converter harness from the front of the CEEMAT and measure the resistance between pins A and E. The resistance should be between 3 and 4,000 ohms or 3 to 4 k ohms. Now, there's a short to ground test too. Clamp one probe to chassis ground. Use the other to probe terminal E. It should be open. This one checks OK. If either of these checks failed, work your way down to the sensor. Disconnect the sensor from the harness and measure the sensor. If we didn't have 3K here at the sensor, replace it. If the sensor's OK, replace the harness. If the readings are within the specifications, you'll have to replace the shift bar cover. Now, a code 24 indicates that the CEEMAT detects a problem in the hydraulic system, and the problem could be caused by something as simple as low oil. If the level is all right, you'll need a few special tools to diagnose the problem: a handheld tester and a hydraulic test kit. Here's what you do. Connect 0 to 300 psi gauges to the main, interrupt, and bypass lockup pressure points. Also connect a 0 to 100 psi gauge to the lube pressure port. Make sure your PTO is in the off position if you have one, and allow the transmission to reach operating temperature. Now, with the engine at idle, monitor the pressure gauges. The main pressure should be 225 to 255 psi or 1550 to 1760 kPa. Interrupt pressure should be 0, and the bypass lockup pressure should be 0, and lube pressure should be 20 to 35 psi or 138 to 241 kPa. If any of the pressures are out of spec, inspect and clean the oil pickup tube and strainer in the oil pan. If they're clean and intact, replace the hydraulic valve. Now, if everything checked out, you'll need to connect the diagnostic handheld tool. Select 1 from the main menu. Then select 1 for CEEMAT. Select 2 to select Perform Test again, and 6 for hydraulic test. Now 1 to select the interrupt test, and 1 again to confirm that the vehicle is in neutral and the parking brake is set. By pressing and holding 1, you will activate the interrupt clutch test. Observe the gauges. They should indicate that main pressure is at 225 to 255 psi or 1550 to 1725 kPa. Interrupt pressure is at plus or minus 5 psi or 34 kPa of main. Bypass lockup pressure is 0, and lube pressure is 15 to 20 psi or 104 to 140 kPa. If any of the pressures are out of spec, replace the hydraulic valve. If everything's okay, press Mode on your handheld tester to go back to the hydraulic test menu. Select 3 to access the lockup clutch test from the menu. Press 1 and press and hold 1 again as you observe the gauges. Main pressure should be 225 to 255 psi or 1550 to 1725 kPa. Interrupt pressure should be 0. Bypass lockup pressure should be plus or minus 5 psi or 34 kPa of main. And lube pressure should be 15 to 20 psi or 104 to 140 kPa. Again, if any of the pressures are out of spec, replace the hydraulic valve. All 30 series codes are associated with the vehicle interface harness, which connects the CEEMAT with the rest of the vehicle. The CEEMAT generates code 32 when it detects a problem with the throttle control or defuel solenoid. Before testing, make sure you know whether the truck has an electro-pneumatic throttle control solenoid, which looks like this, or an electro-hydraulic solenoid like this. So turn the key off and disconnect the connector at the defuel solenoid, and measure the resistance between the pins. A good reading for an electro-pneumatic solenoid is 13 to 18 ohms. The good reading for an electro-hydraulic solenoid is 2.5 to 4 ohms. If the readings are out of spec, replace the solenoid. If the readings are okay, reconnect the harness to the solenoid, then disconnect the vehicle interface harness at the shift bar cover. Measure resistance between pins H and B. Again, you should get the same readings that you got across the solenoid connector. Now, measure between H and ground, and you should get an open or infinity. If the readings are bad, the vehicle interface harness is bad. Repair or replace it as necessary. If the readings are okay, then the problem is with the shift bar cover. Now, Code 33 tells you that the CEEMAT doesn't have battery power, and that means that diagnosing a Code 33 is a little different. You see, you probably won't be able to retrieve a Code 33 using a flash code sequence because you need battery power to retrieve flash codes. You'll need a handheld tester to retrieve the code. But how do you know if you've got a Code 33 without a handheld tester? Well, there are two key indicators. First, if your service transmission light is flashing and you attempt flash code retrieval by turning the key off on, and the service transmission light continues flashing, that's an indicator that you could have a Code 33. Or, if you turn the key off and the transmission powers down immediately without the normal delay, that's another indication that you've lost battery power. You'll want to troubleshoot this problem by measuring the voltage across the battery. It should be somewhere between 11 and 15 volts. We've got a good reading. But if we didn't get a good reading, we'd need to fix the problem with the charging system or batteries. Our reading was okay, so next we disconnect the vehicle interface harness connector from the shift bar cover. Check battery power to the CEEMAT by clipping the black voltmeter probe to battery ground and probing the cavity for pin L. The reading should be within 0.6 volts of the battery reading. This is where it usually goes bad. If you have 0 volts, check your circuit breaker. That's usually where you'll find the problem. Our reading was okay, so next, measure the grounds. Turn the key off and measure the resistance between pin B and the negative battery terminal. Don't clip the black lead to the chassis for this test. You need to go right to the negative battery terminal. Resistance should be less than 0.3 ohms. This one is okay. Do the same thing with pin C. Once again, the resistance should be 0.3 or less. If you find problems during this test, see the troubleshooting guide for help. Now, when the CEEMAT generates Code 34, it's found a problem somewhere in the throttle position sensor circuit. To check the throttle position sensor, again, make sure the key is off and locate the sensor under the hood. Then manipulate the engine throttle while you watch the sensor cable. Make sure there's sufficient sensor cable travel and repair any mechanical problems before proceeding with electrical testing. If the throttle is okay mechanically, start troubleshooting at the throttle position sensor. First, disconnect the vehicle interface harness at the sensor and measure total resistance between terminals A and C. The reading should be 9 to 15 k ohms. We're okay. Now measure between A and B and move the throttle slowly. Resistance should increase smoothly. With the probes between terminals C and B, Move the throttle slowly again. Resistance should decrease smoothly. The resistance between terminals C and ground should be open. If any of these readings fail, replace the sensor. If the sensor is okay, check the wiring harness. Reconnect the harness to the throttle position sensor. Disconnect the vehicle interface harness connector from the shift bar cover and take the reading between pins J and U, which connect to sensor terminals A and C. This measures sensor resistance, and your reading should be between 9 and 15 k ohms. With the probes between T and J, move the throttle slowly. Resistance should increase smoothly with no skips or jumps. With the probes between pins T and U, move the throttle slowly again. Resistance should decrease smoothly. The resistance between pin U and ground should be open. If the readings are okay, both the sensor and wiring harness are okay, and the shift bar cover is faulty, replace it. The first 5 50 series codes, 51 through 55, test the 5 ball switch inputs that signal gear positions to the CEEMAT. Except for terminal numbers, the procedures are the same for all 5 codes. To diagnose any of the 50 series codes, you start by removing the shift bar cover and disconnecting the auto shift harness from the CEEMAT. Now, the troubleshooting guide lists the codes and pins for easy reference. So, locate the appropriate sensor on the auto shifter based on the code we have, let's say code 52, and place a jumper across the 2 terminals. There's a label on each wire pair that marks the switches, S1 through S5. In this case, it's S3. Basically, all we're doing is checking to make sure there's continuity on the wire path between these 2 pins. By placing a jumper there, it doesn't matter if the switch is closed or open. You're checking the integrity of the auto shifter harness. You want to check the harness for abrasions too, because sometimes part of the harness gets pinched under the shift bar cover and can cause a short. Now, check the continuity. On the auto shifter harness connector, probe the appropriate pins. For code 52, it's L and J. The resistance should be less than 0.3 ohms or continuity. Also probe the second pin, J, and a good chassis ground. Resistance should be infinite. If either reading is out of spec, repair or replace the auto shifter harness. If both tests pass, then replace the switch because the harness is okay. See if that solved the problem. If, after replacing the switch, the CEEMAT still indicates a fault code, replace the shift bar cover. We showed you code 52. Fault codes 51 through 55 are all done the same way with the exception of pin numbers. Again, the troubleshooting guide has the codes and pins listed for easy reference. Now, there are 3 important things to remember when you're done here. Don't forget to remove the jumper wire from the ball switch. Reconnect all of the connectors, including the switch and the auto shifter harness. And don't pinch the wires under the shift bar cover. You don't want to create a new problem while you're fixing an old one. Now, code 56 and 57 refer to the shaft speed sensors. Code 56 means the CEEMAT detected a problem in the input speed sensor circuit. Code 57 indicates a problem with the output speed sensor. The speed sensors signal the actual shaft speed to the CEEMAT. The CEEMAT then compares the input and output speeds to synchronize during shifts. So, to perform these tests, again, start by removing the shift bar cover and disconnecting the auto shifter harness from the ECU. On the auto shifter harness connector, probe pins M and C for code 56 or pins N and O for code 57. The resistance should be 3 to 4 k ohms. Since our readings are good, next we probe between vehicle electrical ground and pin M for code 56 or N for code 57. The volt-o-meter should show an open circuit. If the readings on the auto shifter harness are all okay, replace the shift bar cover. If the readings are not correct, you'll need to disconnect the speed sensor with the tool that's provided with the harness. Slide the tool under the rubber boot on the sensor side. You'll feel it click when it releases. Then tug on the wires to slide the wire out. Now take your measurement here at the sensor. If it's good, you can assume the problem is in the harness, and you'd replace the harness. If your measurement is bad, replace the sensor. Remember, when you reconnect the speed sensor, make sure the terminals click together. Tug on them just enough to make sure they're locked in. The 4 60 series codes test the 4 auto shifter solenoids. The solenoids control air pressure to move the shift finger. Again, except for pin numbers, the procedures are the same for all 4 solenoids. So, to diagnose any of the 60 series codes, locate the correct pins in the auto shifter harness. For example, code 61 uses pins T and F. The reading should be 11 to 16 ohms. Now, measure between F and vehicle electrical ground to make sure we don't have any shorts in the harness. The reading should be open or infinity. If it's not, there's a short to ground and you'll need to repair or replace the harness. If both readings are okay, replace the shift bar cover. Don't forget to reconnect all of the connectors, including the sensors and the auto shifter harness, and don't pinch the wires under the shift bar cover. Tests for codes 62 through 64 are exactly the same, with the exception of the pin numbers. Again, the troubleshooting guide lists the pins for easy reference. Well, there you are, everything you need to perform fault code diagnostics. Remember, the troubleshooting guide is your most important tool. It details all of the procedures you've seen in this tape and provides tables, flowcharts, and diagrams for easy reference. Be sure to have it available anytime you diagnose a CEEMAT. Again, if you have questions, refer to the troubleshooting guide, review this tape, or contact your Eaton Road Ranger Field Marketing Network. 1-800-TCM-HELP. Eaton, technology you can depend on.